So today we're starting our unit on functions. We're doing Intro to Functions unit. First thing we need to talk about when we talk about functions is we need to talk about relations and functions and what are the differences between a relation and a function. So with a relation is a set of ordered pairs, or I like to say that it's anything that can be graphed. If you can graph it, it's a relation. There are so many different kinds of things different kinds of relations out there. Like for example, our set of points right there. That's an example of a relation. If I were to have just like a blank graph here, I could have some random points all around, and that would be an example of a relation. I could actually have some kind of a pattern to it. That would be a relation. You could even have like this little spiral thing. That would be a relation. So really anything that can be drawn on a graph or written as some ordered pairs is an example of a relation. So a more specific kind of relation is our function, which is a set of ordered pairs in which the domain, known as your input values, which is also your x values, has only one range value or output value or y value. So really what that's saying is in order to make it a function, your domain cannot repeat. If it does, that means it has more than one output value going with it, therefore it is not a function. So your domain can only exist once. And then some little notation here, our little f with the parentheses and an x around it, red, f of x. That is just our function notation that we're going to start using a lot throughout the rest of the year. So as we were mentioning in our definition of our function up here, our domain input values, that is all your input x values. So if I were to look at our example up here, my domain would be all of my x values, the -2, the 3, and the 4. Those would be my domain. From the example up above, our range would be your y values. Now when you list them out, you do have to have the little squiggly braces there, but you also need to make sure you include them from least to greatest. You always need to reorder them in that way. One way we can tell if we have a function is by using the vertical line test. So if you have the picture of a graph, you want to draw the vertical line on there to see if it is a function. And we're going to do some examples about that in a second. And then this last part here is just telling you there's several different ways to represent relations. You got a table, you can write your set of points, that's the second way, or a graph, that is your third way. So we have several different ways in which we can represent these, and you have to be able to look at each one of them to determine whether it's a function or just a relation. So for example, graph number 1. Since I have a graph, I want to use the vertical line test to determine if it's a function. So I'm going to draw a vertical line anywhere on the graph. And since this hits it more than once, that means this is not a function. This graph is purely a relation. Now, what that vertical line is doing is it's saying at this one given x value, you have 2 y values. You have 2 ranges to go with that one domain value, which as we said, you can't have. You can only have one range value with each of your domain values, which is why we do the vertical line test. If it hits it more than once, it fails. Over here on the parabola, if I draw a vertical line anywhere in the parabola, however, it only hits it once. So this would be a function. So that's saying every x value, every domain value only has one range value that goes with it. So if we're looking at our points here, you want to look at all the x values of your points. So our x values here, I have a 1 that is repeated 3 times. So that means this one value of 1 has 1, 2, 3 different range values that go with it. So because of that fact, that means that these points are not a function. Remember, we can only have one range value for each of our domain. So if we look over here in example number 4, I have different domain values each time. So that means this is a function. Looking at 5, it's the same as 3 and 4. You're looking at just the x value, your domains of your table here. this one is a function. None of those domain values are repeated. But if I look in example number 6, I have a value of 1 that is repeated. So that means this is not a function. So let's take a look at the back. We're going to do some evaluating of our functions, and there's a lot of different ways that they ask you to evaluate functions. So the first one is they'll give you a function, like they did here, and they'll tell you to find a certain value. Now what you have to keep in mind is that number that's right. So what we have to keep in mind is normally we have an x right here in the parentheses. If you look over here, we have an x. Over here we have a 3. So what that's telling us is we're looking for when x is 3. So that's telling us to plug a 3 in for x of our function. So instead of f of x, it's going to be f of 3 equals 2 times 3 plus 5. So if I go through and figure that out, 2 times 3 is 6. 6 plus 5 is 11. So f of 3 equals 11. So in example 8, it's asking the same thing, only it's giving it to you in a table. And it's giving you multiple values to plug in. So it's telling you to plug in a 1 for your n, plug in a 2, plug in a 3. So if we go and figure this out, 3 times 1 is 3, minus 1 is 2. 3 times 2 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 gives us an 8. So then you would evaluate it that way, filling in your table of values. Another way they would ask it is they would say the domain of this function here is this. So this negative 1, 4, 7, that is your domain. What they want us to do is they want us to find the range that corresponds to that. So the way we figure that out is we plug each of those values in for our x. So I would start with negative 1, plug in negative 1, and we would get a 3, because negative 1 plus 4 gives us a 3. So then I'm going to go ahead and plug in a 4. So then 4 plus 4, I would get g of 4 equals an 8. And then we go and we plug in our 7. So 7 plus 4, we would get an 11 for this one. So those three values there, 3, 8, 11, that is our range. However, we have to write it in the same format as they gave us the domain in. So 3, 8, 11. Gotta keep your format the same. So they gave it to you in squigglies for your domain, you give your range in the same squigglies. So another thing they do sometimes is they'll give you either a table of values, or down here they gave us a graph and they're asking you to evaluate the function. It's a little easier because now you don't have to do the calculations like what we did up here. You just have to look at the table. They did all the work for you. So again, you have to keep in mind, inside here is normally an x. So that means we're looking for when x is negative 1. So if I go over to my table, here's x is negative 1. If I look over here, my range value that goes with it is a 4. And that's what they're looking for, is the 4. What is that other value? So here, again, we're looking for when x is a 2. So I go over here to where x is 2. I get a negative 5. And I put this 3 here because that was in front of my function. So that's saying 3 times the function. Well, where f is 2, our function is a negative 5. So I got to do 3 times negative 5, giving me a negative 15. 12, they want us to go ahead and they want us to subtract some of them. So we're looking for where x is 5. So I go to x, go to where it's 5. I get a negative 14. And then they want where x is 0. So I go to 0. I get a 1. So I got to multiply first. I get a negative 2. Subtract those and I get a negative 16. So next they're telling us to write the function rule, and they gave us a format to follow. F of x equals mx plus b. We know mx plus b. We've done a lot of work with this. M is our slope. B is your y-intercept. We just finished this unit on this. So those are the two things we need to know in order to write our function rule. We need to know slope and we need to know the y-intercept. So if you keep reading the problem, they tell us to use these two values, which a lot of people look at are like, I have no idea what this is talking about. We want to write them as points. So this is when x is 0, and this one is when x is 3. So we have our two x values. We just need to find the y values that go along with it from the table. So when x is 0, our y is a 1. When x is 3, our y is a negative 8. So now we have our 2 points, 0, 1, and 3, negative 8. Now if you remember, when x is 0, that y value is your y-intercept. So we know our y value, our y-intercept is a 1. We already have it from one of the points. They kind of gave that to us. We need to calculate our slope. So y2 minus y1 over x2 minus x1. So that gives me negative 9 over 3, which reduces to negative 3. So now we can go ahead and write our function rule. F of x equals negative 3x plus 1. All right, and then our last one here, we're just using the graph this time as opposed to using a table of values, and it's going to work pretty much the same way. Let's go to 15 first. I'm going to come back to 14. These are the ones like we know. We know we're looking for when x is 3. So over on my graph, I'm going to go to where x is 3, go to where it hits the graph at that point, and then look to see what that y value is, which in this case is a negative 1. And then I bring down this minus 1. So negative 1 minus 1 gives me a negative 2. Let's try that again. So we're looking for when negative 2 times g of negative 2. So I'm going to go to where x is negative 2, go down to where the graph is, and look to see what the number is. That number is negative 6. So negative 2 times negative 6 gives me a 12. Now I went over 14 first. I'm coming back to it now because this one's different. They want to know what is the x value. We're trying to find the x value. This is basically the same as saying y. It's interchangeable, your function notation and your y. So we're looking for when y equals 3. So if I draw a line at y equals 3, it hits my graph right there. So then if I look down, that's when x is a 1. So that one's a little different than the other ones because you had your range, you were going backwards and looking for your domain.